This report is about some samples that I received from Mr. Chuck Wade at the UFO Congress back in 2009, and they were from the crash of a small extraterrestrial craft near on the plains of San Augustin, New Mexico, near a town called Horse Springs, and um, so Art Campbell, a historian named Art Campbell, actually found the crash site a few years before, and then Mr. Wade came out there with a bulldozer and actually recovered several pounds of material that the military had missed. This was reportedly the first crash of an ET craft, and it was before Roswell, several days before Roswell. And I assume they hadn't perfected their protocol for recovering crash debris yet, but at any rate, there was more material out there. And he recovered several pounds of material and gave me some samples, 6 samples of different types of material from the crash site. And later on, a few years later, I took an expedition out there with some other people, with Mr. Wade and some other people, and we actually recovered. It's not the second expedition material is not in the report, but we actually recovered a honeycomb material that was very interesting, and it had these brown dots on it that I think are mechanical actuators that I'll talk about more in another presentation. But I also talked to on the second expedition an eyewitness that came upon the crash site before the military got there, and he said it was kind of a horseshoe shaped craft about 40 feet across, and it had a rip in the hull, but was largely intact. And he said that there was a bunch of fiber material coming out of this crack in the hull that resembled fiber optics. And he said that right after he got there, the military showed up and shooed him away. And he said that he saw 2 dead aliens and 1 live one inside the craft before they got there. But anyway, next slide. Next page. So the analytical procedure was that I did low and high power light microscopy on all the samples, and then cut small flakes of each material off to do SEM, and we did SEM and EDX mapping and point and shoot techniques, and then I cut about a 10 milligram piece off of each sample and sent them in for ICP-MS, inductively coupled plasma mass spectrometry analysis. And so that's a technique where you dissolve the sample in nitric acid and send the liquid through a plasma torch and then through a mass spec. And we got the trace element abundances down to parts per billion, and also used the raw data to compute some of the elemental abundant or isotopic abundances for 3 of the elements in the sample, and that gave some very interesting results. I also exposed the samples to a neodymium iron boron magnet to see if they were ferromagnetic, and they were not. And ran a pendulum over the samples because Mr. Wade had done that and got some interesting results. And it almost seemed like the samples were giving off some sort of energy, but the pendulum seemed to be deflected a bit. But we'll have to investigate that further. Anyway, I'm getting ahead of myself. So appearance and physical characteristics of the samples, they were all shards of a silvery sheet metal, which resembled sheet aluminum, and the major component of all the samples was aluminum. These ET craft appear to be made out of, in general, made out of this is a conclusion based on other analyses too, that they in general are based on some of the same materials or same metals we build our craft out of, except that they contain nanostructures and they're kind of smart materials. Electronics and propulsion are sometimes built into the metal. All of the samples, with the exception of number 2 and number 6, had many ridges in the material and a crumpled appearance. So I don't know if they're manufactured like that, or if the crash did that to the samples. Gerald Anderson, the eyewitness, was saying that the foils, probably sample W1, were kind of loosely packed between between the inner and outer hull of the device or the craft, and so perhaps they were involved in producing capacitance or to produce a bifield Brown effect. I don't know if it might have been something along those lines, but all the samples could be bent by hand, with the exception of sample W6. It was a bit thicker. And W6 also had kind of a layered appearance, as if it were made by CVD deposition or something along those lines. Next page. Here are some of the pictures, light micrographs of sample W1. You can see the crumpled appearance, and the surface was very interesting. Some of these samples seem like they might have some sort of a coating on them. I wasn't sure if it was an actual coating, or if it was soil adhering to the material. It seemed like a coating to me on at least a couple of them, and I thought those circular or oval shapes on the surface were very interesting. They could have been microstructures of some kind. It seems to appear very differently from aluminum of human manufacture. Next page. Here you can see that there's some sort of a coating on the material. This is sample W2, and it's very bright aluminum-looking metal underneath. And it could be removed with a knife, but it was bonded fairly well to the metal. Next page. And here's sample W3. This one had more of a bright appearance in many areas. And also you can see some microstructures that were smaller than on the first sample. It just looks very strange compared to most aluminum pieces I've seen before. But it's very interesting that the strength of these materials was not very impressive compared to some of the alien materials or possible alien materials I've seen before. By the way, I used to work for Dr. Roger Lear from 2008 until his death in 2014, and analyzed several alien implants that he removed from his patients. And so I've gathered from that also that a lot of these things are sophisticated nanotechnological devices, and a lot of them contain carbon nanotubes. And we'll see later that there's some indication that these San Augustin samples also may have had carbon nanotubes, although it was somewhat inconclusive in this case. But there were some intriguing indications that there might be some single wall carbon nanotubes present. Next page. Yeah, this sample is very crumpled, W5. Mr. Anderson said that W5 and W1 might have been identical, but the analysis results, I believe, are also very similar. Next page. Here's the sample W6. There's the layered structure that I mentioned, and this sample, in my opinion, definitely had a coating that was applied. You can see that in the bottom two pictures. It was bonded pretty well to the metal, and it just has the appearance to me of a sample that was made by chemical vapor deposition or some other technique along those lines. After this, we did the SEM testing. Next page. Again, we see some structures on the surface that look like they could be microstructures of some kind, possibly adding to the function of the material. One very interesting thing when we did SEM was that there was some sort of interference coming from the material. It was impossible to focus on these samples at much more than 15,000 times magnification. There was a charging problem, but also there seemed to be some kind of interference, as if the samples were giving off some sort of energy. And I saw that with the implant samples I analyzed for Dr. Lear as well. I get the impression that a lot of these alien materials are still functioning on some level, even after catastrophic self-disassembly and removal from the device that they're originally part of. That would make sense if they are nanotechnological devices and have nanostructures and electronics built into the metal. Next page. There's sample W2. This one appeared to have a thicker oxide coating under SEM, and maybe fewer of the possible microstructures. Hard to know what to make of some of this stuff, but it's very interesting. Next page. Another sample. This looks more similar to the first sample under SEM. Some of these samples had ceramic-like crystals and pits. It's uncertain if they were deliberately introduced or were there as a result of some sort of weathering, but I have a feeling they were deliberately introduced. I saw an implant sample that came from Dr. Lear's patient 16 that had pits that were definitely deliberately introduced. So that may be a technology that they use. In fact, I get the impression that nanotechnology in general is old technology to the aliens, and it's things that we're just trying to do just now in the lab for the first time, or things that they've done for perhaps thousands of years. One thing I realized in the course of this research is that I thought going into this that the aliens were maybe less than 1,000 years ahead of us, but I don't think that's the case, because I had some strange experiences after working for Dr. Lear. I also met Dr. Lear because I had a mysterious object appear in my toe after a possible alien encounter. I went to see Dr. Lear, and he x-rayed the toe and found out there was an object there, and he wanted to remove it, and had it removed a few months later. And it was a sophisticated nanotechnological device. And anyway, what I'm getting to is that I went to his office before the surgery to get some tests done on the object and see if it was giving off radio signals, which it was. And he pulled my x-ray out of a stack of x-rays to look at it again, and the x-ray of my toe. And it seems like the aliens like to show off their technology sometimes, because we both couldn't believe it. I knew something was wrong, because when he pulled that x-ray out, his jaw was practically on the floor. And I go, "What's wrong?" And he goes, "Well, see for yourself." He held up the x-ray, and the lettering on the outside of the envelope that the x-ray was in had somehow been transferred to the developed x-ray film. I mean, I don't even know how you would do that in theory. There's no theoretical basis that I can think of that would account for that. how they would do that from a distance, and with the X-ray in question and a stack of other X-rays. It is very strange. I've seen some other odd things that lead me to believe that the aliens are much more advanced than I first thought. But anyway, I digress. Next slide, or next page. Yeah, this is W4. This has a little bit different surface texture. Fewer obvious microstructures, but anyway, people can draw their own conclusions as to what those might be. But those crystals on the upper three pictures look like they could even be some sort of micro antennae, or I'm not sure, but I'm not sure if that's deliberately introduced again, but I suspect they might be. Next page. And this sample has some of the pits I was referring to before on the bottom two pictures. And picture number 4. Those are very interesting pits that look deliberately introduced. This sample is a bit smoother than the others. Sample W5. Doing the SEM shots, it seemed like sample W6 was giving off the most interference, and as I recall, and could not be focused on at very high power. Next page. Here's sample W6, and you can see the layered structure again in this. And it would be very interesting to do electrical measurements under SEM. I think that's possible nowadays, but that's really high end. We weren't able to do that during this analysis, but I think that with some of these samples, doing electrical measurements under SEM with various parts of the material, seeing if there's anisotropic resistance for different resistance one way versus another in the sample, and perhaps doing fast atom etching, followed by EDX mapping to see how the structure varies with depth in the material. Would be very interesting to see if there's a 3D structure to it. I strongly suspect that there is. In fact, I've seen that in another sample that came from a crashed orb from Mexico that was turned out to be a titanium sphere with carbon nanotube electronics inside the metal. Next page. EDX data. The EDX mapping indicated that the elements in the materials were pretty well homogeneously dispersed, and the coatings on the metals were different than the metals themselves. There was a little more silicon, titanium, and nickel in the coatings, as I recall. Next page. Yeah, here's sample W1. The surface had, more nickel and phosphorus, oxygen. So oxides and phosphates and chlorides, perhaps. There's some sulfur in the surface coating as well. So, next page. Here's some EDX mapping. The elements look like they're pretty well homogeneously dispersed, with the exception of the silicon. That's some of those crystals or structures on the surface were apparently silicon dioxide. I also analyzed, Dr. Lear had a piece of what was said to be a piece of the Roswell debris that he got from a friend of his. And supposedly the last owner was killed under mysterious circumstances and given to this friend of Dr. Lear. I don't remember his name offhand. Jim Fueling, I think his name was. I don't know if anybody even know him, but anyway, it turned out to be ultra pure silicon with some very strange impurities that were different than silicon manufactured here, and had a curvature to it. I think it might have been the lining of the reaction chamber, and probably meant to change the heat of the reaction into electricity directly. But I remember there was silver in it, which, you know, there's no silver in ultra pure silicon manufactured here that I'm aware of. And I have a report on that, so maybe I'll present that next time. But next page. Here's a point and shoot of sample W1 and three different spots. So that turned out to be fairly homogeneous, except there's more magnesium and sodium in one spot. So there's some inhomogeneity, but not a whole lot, I guess. I think the bottom EDX spectrum is that little rock in the center, so that the structures have more magnesium and sodium apparently, and silicon. Well, now they're the top one has a lot of silicon too. Anyway, next slide. W3. This is this had fewer elements in it apparently. Beryllium showed up. I'm not sure if that's an artifact or if beryllium was really present. I don't think the ICP-MS showed much if any beryllium, but we'll have to see when we get there. I don't think there was. Sample W3. Next slide. Yeah, no beryllium in this one. Very similar. Yeah, they were all very similar, but there were some differences. I remember I think it was sample W4 had the most iron, and there was another one with a lot of zinc. And next page. Yeah, they're all very, very similar. This is sample W5. Next page. I did two EDXs here on W6 because I wanted to show the difference between the surface coating and the metal. The W6 obviously had a coating on it, and I'm not sure why there was that big titanium peak in the EDX here. There wasn't too much titanium in these samples. That must be an artifact of some kind. Palladium showed up in this sample, and that's very strange. And a lot of chlorine in the coating part of it on the bottom, and so there were sulfur. So chlorides and sulfates, perhaps. Next page. And magnetic and electrical analysis. I tested all the samples with an ohmmeter, and they all conducted electricity. And none of them were attracted to a neodymium iron boron magnet, so they weren't ferromagnetic. I'd be surprised if they weren't a little paramagnetic because they had significant amounts of iron in them, but as evidenced by the ICP-MS. But I wasn't able to determine quantitative values of sample resistivities because the samples are sort of irregular in shape and thickness. But if we do any more testing, we could probably figure that out. And Raman spectroscopy, there were some intriguing indications there could be carbon nanotubes present, but I'd say overall it was somewhat inconclusive, except for sample W1. I thought at the time had the most indications of having carbon nanotubes present. The one sample that I analyzed for Dr. Lear, and it came from patient 16 that had the pits in it I was talking about before, also had the highest concentration of carbon nanotubes that I'd seen in all these samples. There was no question that sample had carbon nanotubes. I didn't see any carbon nanotubes on the SEM shots because apparently it was dispersed extremely well in the metal. The material was dispersed extremely well in the metal, and you couldn't see them. Probably they were probably present as individual tubes, but in any event, that material was incredibly strong, and it took a high energy laser to cut it. Diamond tools wouldn't cut it. We usually cut these samples in half to see the interior in the case of bulk pieces like implants, and regular tools and diamond tools wouldn't cut it, so we had to use a high energy laser, and that would definitely follow from the fact that there were carbon nanotubes present in the material, and they were highly dispersed in the metal. Carbon nanotubes are the world's strongest known material, and right now in earthly science, we're trying to make well-dispersed carbon nanotube metal matrix composites like that for high-strength applications. And since carbon nanotubes also have electronic properties and can be used as transistors and diodes, it's theoretically possible to disperse carbon nanotubes in the metal in a 3D structure and use them as electronics built into the metal, which I think is what the aliens are doing in a lot of cases like this. Next slide. There were some peaks in sample W1, which I believe later turned out to be peaks from aluminum oxide, but in the high frequency or high wave number region. But in the low wave number region, there were a couple of peaks that could have been single wall carbon nanotubes, and it'd be very interesting to dissolve some of this material in acid and see if any carbon nanotubes were left behind. If I were going to go back and retest these samples, that's part of that was one of the things I would do. Carbon nanotubes are also very resistant to chemical dissolution or oxidation. They survive in air up to about 500 degrees Celsius or higher. And in vacuum, they'll go up to like 2,000 degrees Celsius. They're very, very stable and very strong. And you can change the electronic properties of them by putting different metals inside. I actually have a patent on that. They're conductive in such a small diameter that the Casimir effect can actually suck things into the interior of a carbon nanotube. I don't know if you're familiar with that, but it's a vacuum. It's a quantum vacuum force. If you have two, say, sheets of conductive material close enough to each other, it does not allow virtual electromagnetic radiation of greater than that wavelength of the spacing between the plates to propagate between the plates. And so there's more pressure from the 0-point energy outside the material than inside. And it leads to a very strong force pushing things together if two conductive materials are spaced closely enough. And that also applies to a conductive tube, obviously. Next page. Okay, now we're down to the ICP-MS analysis. We tested for 68 elements. You can't test for every element with ICP-MS, like iodine, sulfur, volatile elements are not able to be tested for. We detected 56 elements in at least one sample. I think that was sample W6, as I recall. And aluminum, of course, was the biggest contributor and most abundant element in the samples, and followed by iron, silicon, calcium, manganese, magnesium, potassium, titanium. And this is very unusual for a human. It would be very unusual for a human-made aluminum alloy. That's a lot of elements to be present. I think usually there's only like 3 or 4, or at most 5 or 6 elements present in human-made alloys. And I've got a table later on of the abundances in each sample. Next page. Yeah, here it is. Here it is by sample, and it's more instructive to do it by average abundance. Next page. Next page. Here we go. So in all the samples, aluminum was the matrix material, the number one material, then followed by iron. 7,600 ppm of iron in W1, and W2 had 7,100, 8,800 in W3. Yeah, W4 had the most iron with 111,000 ppm. That's like 11%, I believe. And W5 had a lot less, 5,100 ppm, 4,500 ppm in W6. Silicon was a big contributor to 2,600 ppm in W1 and less in the other samples. I kind of hypothesized that these samples may have been acting as electrical conductors, and if so, perhaps they used iron and silicon for maybe for other reasons too, but because iron and silicon do not interfere with the conductivity of aluminum as much as other alloy ingredients would. We have calcium, manganese, magnesium, potassium, titanium, copper, phosphorus, zinc, sodium. It's hard to get a feel for all this without staring at it for quite a while. But there was some rare earths here too, which I found interesting. I heard a while back they were doing experiments to strengthen aluminum using rare earths. So perhaps that was part of the reason for their presence. There's gadolinium, praseodymium, neodymium, and a couple other rare earths, I think, too. Next page. Yeah, we have dysprosium, Dysprosium and I think it was ytterbium were present in those brown dots that we thought might be mechanical actuators on the honeycomb sample I mentioned. And europium, there's quite a few rare earths in here. A little bit of erbium, a little bit of iodine, samarium. Yeah. Very strange. Rare earths have very strong magnetic, a lot of them have very strong magnetic properties. Perhaps they're in there to alter the magnetic properties. It's hard to say at this point, but it's very difficult to think that, strange to think that they would put all these elements in there without them having some definite purpose. And I don't think that they have the capability to manufacture this kind of stuff back in 1947. And it's possible it could have been part of some top secret government project, but personally, I kind of doubt it. And at a table there about the amount of iron, calcium, and magnesium on the different samples. W4 had the most iron, and a little easier to see that way. Next page. Here we go. Potassium, titanium, copper, phosphorus, zinc, sodium, and W6 had the most zinc. Again, I'm not sure what that means, but it's very strange. There's that zinc's not a very common alloying element in aluminum. I've never heard of it actually. And sodium and sample W1, that could be contamination, I suppose. But I did rinse off these samples thoroughly before analyzing them. But they were buried in the ground for a while, so hard to say if that's contamination or not. Next slide. And I did isotopic analysis of sample W1 using the raw data from the ICP-MS analysis. And I've seen before that it's very interesting that the sample isotopic abundances are skewed in antimony, copper, and nickel. I use those three elements because there were no significant interferences with other ions or isotopes. And the isotopic abundances are very skewed compared to the terrestrial ones. On the right, you see the terrestrial isotopic abundances in each element, and then the sample isotopic abundances on the left. And in each case, you see that the heavier isotopes of that element are overrepresented in the sample, and they're extremely skewed compared to terrestrial abundances. Dr. Lear and I thought that this is way too strange and way off to be from Earth. It couldn't possibly be from Earth. In fact, it probably couldn't even be from the solar system. You can tell what celestial body each sample comes from, usually by the isotopic abundances, and they're off a little bit compared to Earth on like the moon or moons of Jupiter, or any place else in the solar system, asteroids that come down. But they're usually off by way less than this. I would say that either these samples came from closer to the center of the galaxy, where there's heavier supernovas that synthesize these things in the first place, and higher neutron fluxes during the supernova explosions, synthesizing more of the stable, heavier isotopes of each element, or they've been exposed to a very heavy bombardment of neutrons or other nucleonic particles. Either way, they're extremely strange, and I'd say this gives a very high probability that the material came from off planet. One very strange thing about some of these things is that a couple of times they seem, when I did the same test that Dr. or Mr. Wade said he had done. The sample seemed to deflect a pendulum. I'm not sure what's up with that, unless they're giving off some sort of energy, but we need to do further tests on these materials to see if that might be the case. I did the tests at the 2010 UFO Congress in Laughlin, Nevada. And next slide. I was left a little bit perplexed by some of these things. I mean, there were some indications that there were carbon nanotubes in the material, but the mechanical strength wasn't too impressive, which was kind of surprising. That sample W6 had a layered structure, which was very strange and very unusual. So the isotopic analysis was very, very telling, though. I mean, I think that these have to be from off planet, unless the data is completely off, which I doubt. We need to do more isotopic testing at other labs to confirm this. Next page. And the sheer number of elements in the material was very very strange and indicates they were very unusual. And the rare earths, that usually don't see that in aluminum. They're very strange samples, but I was just kind of surprised that they weren't ultra strong or have other unusual mechanical properties. But then again, we don't know that they don't under certain conditions. I mean, we need to do more testing. There's a lot of this material available. Mr. Wade has at least a couple pounds remaining of this material, I'm pretty sure. And anybody that wants to get some of this material might want to contact him. He was very anxious to give away some of the material for testing last time I heard. Next slide. So conclusions, these samples contain very unusual alloying elements which are not present in aluminum alloys in 1947. If the samples are from an aircraft of that era, they're very unusual on that basis. And the coatings on the samples are very unusual because conformal coatings of this type were probably not available in 1947. The coatings are also somewhat similar to coatings on implants removed from people claiming alien contact. And the carbon nanotube indications are really intriguing. And if true, there might be smart materials which contain carbon nanotube electronics or to strengthen the material. Since the mechanical strength of the samples was not unusual, they should be tested for unusual electrical characteristics. I suspect they would show very unusual electrical characteristics. And the isotopic ratios of the elements in sample W1 that were able to be tested for, as I say, were very, very skewed and consistent with coming from a very far away extraterrestrial source or being exposed to a high flux of nucleonic particles at some point. Either way, it's very, very unusual. And they're reminiscent of isotopic ratios also obtained from alien implants and from an alleged piece of the Roswell crash debris, which was analyzed by the late Dr. Russell Vernon Clark. Dr. Vernon Clark analyzed a piece of the silicon sample that Dr. Lear had that I mentioned, and apparently had some sort of problem with the government afterwards and disappeared. I don't know whether he is still alive or what the deal is, but it was very, very, very strange. And Dr. Lear said he just stopped answering his phone and nobody knew what happened to him. But anyway, the report is in the back of, I included the report as an appendix in this report if people want to read it. The results of the pendulum test indicate that the sample samples may still be emitting some sort of energy, and we should test for something like that. And further microscopic testing should be done on these materials to determine their internal structures. Like I was saying, more testing like with fast atom etching followed by EDX mapping, perhaps, and micro resistance measurements. I think at this point I'd like to open up the talk for questions.